Have you ever looked up at the night sky and felt a sense of wonder? A feeling of smallness, perhaps, mixed with an immense curiosity. What is out there? Where did it all come from? Are we alone? We have built tools to help us find the answers, from the simple telescopes of Galileo to the powerful observatories that dot our planet. But now we have something new. A golden eye, floating silently in the cold darkness of space, 1,000,000 miles from home. This is the James Webb Space Telescope. Not just another telescope, a time machine. You might be familiar with the Hubble Space Telescope, our faithful eye in the sky for over 30 years. Hubble showed us glorious images of colourful nebulae and swirling galaxies, opening our minds to the beauty of the cosmos. It sees the universe primarily in visible light, the same kind of light our eyes can see. But there is a whole spectrum of light that is invisible to us, and that is where the Webb telescope truly shines. Webb is designed to see the universe in infrared light. Think of it like having a pair of cosmic night vision goggles. This allows it to see things that Hubble and we could never hope to see. As the universe stretches, the light travelling through it also gets stretched. Light that started as ultraviolet or visible becomes infrared by the time it reaches us. Webb's giant golden mirror is specifically designed to collect this faint infrared glow, giving us a front-row seat to the cosmic dawn. Infrared can pass through clouds of cosmic dust and gas. For Webb, these clouds become transparent, like having X-ray vision for the cosmos, revealing the fiery birth of stars and planets. With this new power to see in infrared, the James Webb Space Telescope is doing something extraordinary. It is looking so far away that it is actually looking back in time. The light from our sun takes about 8 minutes to reach Earth. So when we look at the sun, we see it as it was 8 minutes ago. When Webb observes a galaxy 1 billion light-years away, that light has travelled 1 billion years to reach Webb. We are seeing that galaxy as it was 1 billion years ago. Webb pushes that limit to the extreme. It can detect objects over 13.5 billion light-years away. The universe is about 13.8 billion years old. So this is remarkable. Before Webb, images of the early universe were blurry and indistinct. Now Webb delivers crystal-clear images from that ancient epoch, like finding a long-lost photo album of the universe's childhood. We see the first collections of stars, small, clumpy, chaotic galaxies, the building blocks that merged into larger structures. These observations challenge and refine our models. Webb doesn't just give answers, it gives better, more interesting questions. The discoveries from the James Webb Space Telescope are not just about time, they are about size. Our galaxy, the Milky Way, contains somewhere between 100 and 400 billion stars. Our Sun is just one of them. Imagine we shrink the Milky Way to the size of North America. On that scale, our solar system would be smaller than a coffee cup. Earth would be an invisible speck of dust. For a long time we thought there were perhaps 200 billion galaxies. Webb's deep fields, a patch no larger than a grain of sand held at arm's length, are packed wall to wall with galaxies. The estimate may rise from 200 billion to something closer to 2 trillion, 2,000 billion galaxies. Our continent-sized galaxy would be lost in that sphere. Travelling at light speed, it would take millions of years to cross the observable universe. The universe is not isolated islands. It is a continuous, interconnected web of structures on a scale that defies everyday intuition. Every empty-looking patch of sky is teeming with worlds, suns and galaxies stretching back to the beginning of time. It is humbling and also awe-inspiring. So what exactly has Webb found in this vast, ancient expanse? It has given us our first clear look at the pioneers of the cosmos. One exciting discovery is a candidate for the most distant galaxy ever observed, an object named JADES GSZ 13-0. The light from that galaxy travelled for over 13.5 billion years. We see it as it was just 320 million years after the Big Bang. It is little more than a tiny reddish smudge, but that smudge is a window into a time we have never seen. These early galaxies are small, clumpy, irregular, like cosmic building blocks. Galaxy formation was messy and chaotic. Small collections of stars collided and merged, gradually building larger and more complex structures. eventually forming grand spirals like our Milky Way. Beyond images, Webb analyzes light via spectroscopy. Breaking down the light tells us which chemical elements are present, hydrogen and helium at first, heavier elements later from stellar furnaces. The very first stars forged heavier elements in their cores and explosions, oxygen, carbon, iron, seeding future planets. Webb also peers at nearby targets, protoplanetary disks, exoplanet atmospheres, detecting water vapor and chemical fingerprints that hint at habitability. Faced with overwhelming scale and antiquity, it is natural to feel a sense of insignificance. If the universe contains trillions of galaxies and our galaxy contains hundreds of billions of stars, what does that make our small blue planet? Instead of feeling small, perhaps we can feel precious. We are extraordinarily fortunate. The long chain of events had to occur for us to be here. The Big Bang, the first stars, supernovae forging heavy elements, clouds collapsing into our sun and planets. The iron in our blood, the calcium in our bones, the carbon in our DNA, all forged in stars that have long since vanished. We are literally made of stardust. We are the universe made conscious, a way for the cosmos to know itself. The Webb telescope is an extension of our senses and our minds, the embodiment of collective curiosity. By sending this golden eye into the dark, we are not diminishing ourselves, we are expanding ourselves, connecting to the grander reality of which we are a part. For all that Webb has revealed, its greatest gift may be the new questions it forces us to ask. We see surprisingly mature galaxies very early on. How did they form so quickly? Was there an unknown ingredient or process in the early cosmos? Are our fundamental models incomplete? We can see only about 5% of the universe. The other 95%, dark matter and dark energy, remain mysterious. Webb helps map dark matter more precisely, but it cannot see it directly. The more we learn about the visible 5%, the more pressing the mystery of the rest becomes. Webb studies exoplanet atmospheres, searching for biosignatures, oxygen, methane, water vapor, chemical fingerprints that might hint at life. Finding such a signature would not be definitive proof, but it would be the most tantalizing clue in human history. With trillions of galaxies and countless planets, statistics suggest life could be common. Yet we have not found it. Is life rare, or have we not looked in the right way? Science thrives on the unknown. The universe Webb shows us is not a finished story. It is a vast, open book, and we have only begun to read the first page. We find ourselves at a remarkable moment in history. For the first time, we have the technology to look back to the beginning of time and across unimaginable distances. The James Webb Space Telescope is our guide on this journey, patiently gathering light that has traveled longer than the Earth has existed. It collects stories of the first stars, the first galaxies, and perhaps the first hints of life elsewhere. The images and data it sends back are more than science. They are a form of cosmic art, a new story of creation. Seek out the latest images from Webb, read about the discoveries, share them, talk about what they mean. Let the scale of the universe inspire you, not with fear, but with awe. Remember, we are all crew members on this tiny, precious spaceship called Earth. The desire to understand is one of the noblest parts of the human spirit. Let us nurture that desire. Let us stay curious. The universe is waiting. Its secrets are written in light, and for the first time, we know how to read them. The journey ahead will be long, filled with challenges and surprises. The next discovery from Webb could come tomorrow, or next week, and it could change everything we think we know. The age of discovery is not over. In many ways, it is just beginning. I invite you to follow along on this incredible journey. Seek out the latest images and read about the new discoveries. Share them with friends and family. Talk about what they mean. Let the scale of the universe inspire you. Thank you for joining us on this small part of that journey today. If you have been inspired by the wonders we discussed, please take a moment to like this video and subscribe to Cosmic Discover. Stay curious. Please like and subscribe to Cosmic Discover.